Okay, so we're looking at how to take the derivative of an inverse of a function, okay? The cool thing about finding the derivative of an inverse that we will see as we go through this, you don't actually need to know the inverse function to take the derivative of the inverse. You can take the derivative of an inverse of a function just by knowing the original function. So let's review what we know about functions and inverses. So if I have set A and I have set B, and there is some function that's going to take every element in set A and convert it to an element in set B. Let's call that function f of x. Then the function that takes an element from B and converts it back to an element in A is the inverse function, correct? So if I think of set A, let's just, for example, say that this set A is temperatures in Fahrenheit, and set B is temperatures in Celsius. Is there a function that will convert it to Fahrenheit to Celsius? Is there an inverse function that will convert Celsius back to Fahrenheit? Okay, so the domain of my original function is A, and the range of my original function is B, right? Function takes elements from A to elements in the range B. So what is the domain of F inverse? B. We are taking elements from B and converting them into elements in A. So let me get this straight. The range of my original function is the domain of the inverse. And the domain of the original function is the range of the inverse, right? And let's go back to Algebra 2 or to pre-calc. Do we remember how we found an inverse? How we found an inverse function? Didn't you switch x and y and then solve for y? It's embarrassing, me being your pre-calculus teacher, and this was on a stinking test. And go home and cry. Right? So let's look at this. What?
An idea of what we might do to get the derivative of.
Are you thinking ahead?
Yes.
Oh my gosh. I hate when that happens. I hate when kids try to take what I'm telling them and see how we can use it and apply it. That's sarcasm alert. Okay, so the domain of my inverse function. So if A comma B is a point on f of x, the domain value on my original function is the range value on the inverse function, right? If this was degrees Fahrenheit converted to Celsius, degrees Celsius converted back to Fahrenheit, it better be the y value, correct? And the range value, the y value on my original function is the x value in the inverse. Okay, so if I told you that f of 2 is 6, isn't that an ordered pair, 2 comma 6? then what do I know is true about F inverse? F inverse of 6 is 2. So if I know a point on the original function, I also know a point on the inverse function, right? Does that make sense? So if I told you F of 3 is -4, what else do I know? F inverse of -4 is 3, right? Does that make sense? We understand that. The x and y, the domain and range change places on the inverse function. So, for the derivative of an inverse function, we are going to let f be a function that is differentiable on an interval. And if f has an inverse function, we're going to call it g. Then g is differentiable at any x for which the derivative f prime of g of x does not equal 0. Okay? You don't understand that yet, but I'm going to show you. Okay? They did tell us that g is the inverse of f. So f inverse of x is g of x, correct? How many of you are still writing that down? Okay.
Wait, did you say that g of x is the inverse of f of x?
Mm-hmm. Isn't this saying that I'm plugging the inverse function into the function? Does anybody remember what happens when I plug an inverse into it, the original function, the inverse into the original function? Like for example, oh, I can't do that. Not touch screen. There we go. So I'm gonna do f of g of x. Okay, so g of x would be this one. So I want to do f of g of x. So I'm gonna convert it to, well, if I start from the inside, I'm gonna convert from Celsius to Fahrenheit, and then I'm gonna do the f function from Fahrenheit to Celsius. What am I gonna get? What I started with, right? X, right? Whatever I plugged into the, because they're undoing functions. That's what inverse functions are. They're undoing functions. The square root of x squared is. The cube root of x cubed is. Right? They're undoing functions. So, do you agree that when I plug the inverse into the function that I'm going to get x? Right? They undo each other. I get what I started with. So now I'm going to use, well, I guess it's not implicit differentiation. I'm going to take the derivative of both sides. So I have to use chain rule on f of g of x, right? So I have derivative of the outer function times the derivative of the inner function. Do you agree with that? Derivative of the outer function times the derivative of the inner function equals, what's the derivative of x? 1. Now, the whole thing that we're talking about is the derivative of the inverse. Isn't that this? Isn't that the derivative of the inverse function, g prime? So can I solve for g prime? The derivative of the inverse is going to be 1 over f prime of g of x. And what did I say right here? This is true as long as f prime of g of x does not equal, because I can't divide by 0, right? As long as the derivative of the outer function f prime of g of x doesn't equal 0, this will be the derivative of the inverse function. You need to memorize that. Okay? I always give myself more space than I need until I don't, and then I don't give myself enough. So I'm never quite right. Okay? So we want to find g prime of 8. G is the inverse of f of x. So g prime of 8 is going to equal 1 over f prime of g of 8, right? Isn't that what this formula says? Isn't that what it says? You agree with me? So I need to know 2 things to be able to evaluate this. I need to know what g of 8 equals, and I need to know what f prime of x is. Do you agree with that statement? All right, so which one's the easy one? F prime of x is what? Negative 2x, correct? You with me? All right. So g of 8, stinkopotamus. I don't know what the g function is. But don't I know that f of question mark will equal 8 if g of 8 equals question mark? Isn't that true? If they're inverse functions? Isn't that what we just did up here? That's what we did right here. If I know a point on the function, I know a point on the inverse. So f inverse of 8 equals question mark means f of question mark equals 8. Does that make sense? I'm just switching, right? So that means I need to know, where does 9 minus x squared equal 8? So if I'm solving this, I get 1 equals x squared, which means x equals plus or minus 1, right? But what was our domain? We were looking from 0 to 3, so that means I just need the positive one, correct? So what that tells me is f of 1 equals 8. So what does g of 8 equal? G of 8 equals 1. So now let's evaluate this. So this is 1 over f prime of, what was g of 8? G of 8 was 1. What is f prime of 1? G prime of 8 will be negative 1/2. And I did not have to find the inverse function. Does that make sense? Who's still copying that down? Yes.
So with x squared and the square root of x, if we're going to try to find the inverse of x squared,
You have to have it.
It's 1 over the outer function, which is where you get the 2. The derivative of the outer function and the inner function is that's where you get the 1 over 2 square root of x. Is that right?
Okay. Anyone still writing this down? Okay, so you got a group. If you're not in a group, now let me tell you, you're going to want a graphing calculator because you're probably going to want to use the calculator to solve where this equals. I'm not necessarily expecting you to do that by hand. Okay? There's just no rhyme or reason whatsoever in how you're just randomly grabbing calculators. You hate calculators? You use it all the time. Yeah.
I've heard that sounds like helpful. It's like good to have in the real world. Have that kind of
Especially going into an election year because you're going to be bombarded with statistics and different sides of the argument are going to give you, they're going to use statistics to try to sway you. And more often than not, they're pulling their statistics from the same study. It's just how you make it work. Yep. Whose is this one?
Or you could, Ms. Burleson could use our prep here. It's 2 minutes. So it's for a reasonable sum. You didn't hear that from me. Okay. All right. There's a question on
I'm purple.
that. So like,
My dad was so proud. My dad's favorite color. You don't know.
Wait, isn't that?
I mean, he's 77 years old and his favorite color is still purple. And most of the time when he dresses up to go somewhere, he wears black and purple.
Oh wait, my bad. Oh. Wait.
So let's pause for a minute. What is this going to be? G prime of 1 is going to equal what? 1 over f prime of g of 1, right? How many of you got that right? Okay. And then what is f prime of x? I'm assuming we did that.
Yeah.
Is that what we got for f prime of x? Okay. So now, how are we doing on this g of 1? So how many of you did this? That means f of whatever is going to equal 1, which means 2x plus cosine x equals 1. And then you didn't listen to me and you tried to solve it by hand, which we can't do. Okay, so there are 2 ways to do this on the calculator. Okay, let me show you both ways to do this on the calculator. We can graph 2 minus the sine of x, and I want it to equal what? I want to know where it equals 1. So I'm going to graph, not 2 minus. Sorry. I did the wrong thing. My brain is remembering. This is where I wanted to be. This is 2x plus, I was remembering the last one I did, cosine of x. There we go. And I want to know where that equals 1, correct? So then when I graph this, where are they equal? Does it appear to be at 0? Does it appear that the x value will be 0? Let's make sure. So I can go second calc, intersect, and then I have, see how it's blue on the first curve, and then I hit enter and the colors switch to red on the second curve. It always gives me a chance to guess. Thank you and no thank you. Just tell me. So I hit enter once again. What is the x value where they are intersecting? X is 0. So here is what the expectation is when you use your calculator to solve. Did I write the equation that I am solving? You can go straight to x equals 0. Okay. You said there was another way we could solve this. You could go 2x plus cosine x minus 1 equals 0. And then here, oops, cleared the wrong one. 2x plus cosine x minus 1. Now I want to find the 0. And then I want to be to the, to the right of it. Did I give me a left bound? Right. That's what second calc 0. I want to be to the left of it. And then I want to be to the right of it. Uh-oh. This is negative 2.17 times 10 to the negative 14th. That's just 0 because there's a rounding error with your calculator. If I even rounded to 12 decimal places, I'd get 0. Okay, so this is basically 0. So those are the 2 ways you can do it. You can solve so that it's set equal to 0 and find a 0, or put both of them in and find where it intersects. So now I know that x equals 0. So that means f of 0 is 1. So what is g of 1? So I now have 1 over f prime of 0. How many of you were able to do this solving on your calculator? Okay. How many of you were not sure how to do the solving on the calculator? Okay. That's one of the reasons I wanted you to try this first. I wanted to see if you remembered how to do it, because I will tell you on the AP exam, and on my tests, if you have a calculator and you need to solve, don't do it by hand. On the AP exam, they are assuming if it's calculator active, you're using your calculator to do these solutions. Don't do it by hand if you don't have to, okay? So now what is f prime of 0? What is sine of 0? It's not always going to be a half. Just the two examples that I gave ended up being that way. Does that make sense? And I never had to find the inverse, which is really nice because the way we know how to find an inverse, we couldn't do on this one. We can't find that function. We don't have the mathematics at our disposal to find the inverse of that function, but we can still find the derivative of the inverse at a value. Any questions? 12 minutes left. Yeah.
What would it look like if it didn't zero? Where the calculation?
I don't know what you're saying. Like, what if f prime, what if I did this? Like that?
No, like, in the derivative of an inverse function, it says that f prime of g of x equals.
Oh, if that equals 0, you can't find the derivative.
Where would you find that out? Like, so,
When you plugged in here, so you would have gotten I can't have that, right? Because if f prime of g of x equals 0, or g of whatever equals 0, that's where I get that. I can't divide by 0. You would find it once you got to that point. Problem. Okay. And in that case, you wouldn't be able to find the derivative at that point. Any other questions? Good question. Sorry, I misunderstood it at first, what you were asking. Yeah.
If we like did enough with that, would we just stop there? Would we have to say like can't find it?
If you're asked to find the derivative at that value, I've not seen any problems where you couldn't find it. What that would be a question more like, can you find the derivative? Can you find g prime of whatever? Versus what is g prime of whatever? So in that case, you would say you cannot find g prime of x because f prime of g of whatever equals 0 for this value. Good question. Any others? I know on my test, if I ask you to find the derivative of the inverse at a point, you can find it. That's not going to be a, haha, I tried to fool you. It doesn't work. Okay. We good? Okay. Nope, this is what I wanted to do.